in Unit 1, we were solving equations. Unit 2 is more solving equations, but we have variables on both sides of the equation this time. So it's a little bit different in what our stuff looks like. So, when we are solving an equation with variables on both sides, we have one big overarching goal, and that is to get all variables on one side and all constants on the other side. Okay, so that's our goal. Our goal is we want to get all variables on one side, all constants on the other side. Okay, so we do have, for solving these things, step 1, we're going to use distributive property or combine like terms on each side if necessary. Okay, so that means that we might have to do distributive or combine like terms on both sides at the same time. Okay, and then we're going to first move all variables onto the same side of the equation. And I give you guys a hint. Move the negative or the smaller one. Okay, so if there's a negative variable, move that one. If there's not, move the smaller one, because that's going to keep all of our x's positive. Okay. Step 3, you want to get all constants on the other side. So if we put all of the variables on the left, we want to put all of the constants on the right. If we put all of the variables on the right, we want to get all of the constants on the left. Okay, so we want them on opposite sides, because then we can solve as normal. Okay. Alright, so example 1, I have 7x minus 9 equals x plus 3. Okay, so step 1 told us to use distributive property or combine like terms on each side. So let's look at the left-hand side. Is there a distributive property there? No. No. Is there combine like terms? No. No. Okay, so look on the right-hand side. Is there distributive property here? No. No. Is there combine like terms? No. No. Okay, so we can move on to step 2. Get all variables on the same side. So let's look at our variables. I have 7x and x. Which one is smaller? X. So we need to get x to the other side. So how do I get positive x to the other side? Subtracting x from both sides. Why do we subtract? What's x minus x? 0. So they cancel. So what's 7x minus x? 6x minus 9 equals positive 3. And this is now a two-step equation. So, let's see. What do I do to solve for x? Who's in 30? Nobody. Who's in 1? Aaron. What do I do to solve for x?
Well, so do the inverse.
Inverse, okay. Which one?
9.
9. So what's the inverse operation here?
Plus 9.
Add 9. Very good. 9 minus 9 gives me what, guys? 9 minus 9?
0.
0. So that gives me 6x, or negative 9 plus 9, sorry. Still 0. Equals 3 plus 9. 12. There you go. Okay. Alright, so I have 6x equals 12. Am I done, Omar? I divide by what? Very good. I divide by 6. Okay, everybody, pop quiz. What is 6 divided by 6?
1.
1. So that leaves me with x equals 2. How do I know if I got the answer correct?
Plug it in.
Plug it in, plug it in. So let's plug it in. 7 times 2 minus 9 equals 2 plus 3. So we should get the same number on both sides. Okay? Alright, what's 7 times 2 going to give me? 14. So 14 minus 9 equals 2 plus 3. What's 14 minus 9? 5. What's 2 plus 3? 5. Are those the same? Yes, they are. So we got the correct answer.
Yes, sir.
Okay? Thumbs up, thumbs down on this. How do you feel about it? Okay, good. All right, example 2.
I've been writing this out.
3x plus 1 equals 4x minus 12. 3x plus 1 equals 4x minus 12. Good. Okay, so step 1 said use distributive property or combine like terms. Who's in 15? Angel, do you see distributive property or combine like terms anywhere in this problem? No. Okay, so we get to move on to step 2. Step 2 says get all variables on the same side. So our hint is to move the negative or the smaller one. So between 3x and 4x, which one do I want to move? Marcus. Why do I want to move the 3x? Because 3x is smaller than 4x. So subtract 3x from both sides. What's 3x minus 3x, ladies and gentlemen?
0.
0. So we get 1 equals 1x minus 12. Did anybody move the 4x instead of the 3x? You can do that. You will still get the same answer. The only reason why I prefer you to move the smaller one is because then we get to keep our x's positive the whole time. So if you move the 4x, you would have had a negative 1x. And then you have to worry about getting rid of that negative later. Okay? So I suggest that you move the smaller one because then x's stay positive the whole time. Okay? Step 3 says get all constants on the other side. So what am I going to do in my next step? Stephanie.
Move the negative 12 to the other side.
How do I move negative 12 to the other side?
Subtract 1.
Okay. This is a good time for everybody to go back to the first page of your notes. Everybody look at the top of your notes.
What's that?
At the count of 3, I want you to read what our goal is. So what is the goal? Find it. Put your finger on it. Everybody read me our goal. 1, 2, 3. Very nice. So, all of my variables on the right-hand side. So what side do I want the constants on? On the left. So if I subtract 1, will that give me all constants on the opposite side as the variables? If I subtract 1, it'll move it over here. Does that put all my constants on the other side? No, it puts them on the same side. So what should I move? The 12. How do I move the 12? Very good. I add 12 to both sides. Okay. Negative 12 plus 12 gives me 0. 1 plus 12 gives me 13 equals x. Or I could also write x equals 13. It's the same thing. Okay. Okay, let's check it really quickly. So we have check. 3 times 13 plus 1 equals 4 times 13 plus 1. Or minus 12. Okay, 3 times 13 gives me 39 plus 1. And 4 times 13 gives me 52 minus 12. 39 plus 1 gives me 40. And 52 minus 12 also gives me 40. True statement, so we got the correct answer. Okay. Example 3. 6 times x minus 4 equals negative 4 times x plus 1. Okay, this problem is a little bit different because what do you all see that we haven't seen yet? Distributive. So on both sides, distribute the 6 and the negative 4. So 6 times x is going to give me 6x minus 6 times 4, 24, equals negative 4 times x, negative 4x, negative 4 times 1, minus 4. Okay, there's no combined like terms, looking at both sides, so we have to get all of our variables on one side. So, Which one do I want to move? The 6 or the -4? Good, the -4 because it's negative. Okay, so add 4x to both sides. Because -4x plus 4x gives me 0. 6x plus 4x gives me 10x. Minus 24 equals -4. Okay, so that negative stays attached to the 4. And this is a two-step equation, so we add 24 to both sides. And that's going to give me 10x equals positive 20. So then this should be easy. Divide both sides by 10. X equals 2. How would I check my answer? Plug it in, plug it in. Okay. But we have to keep moving. All right, example 4. Uh-oh. Ew. We have -2 times 2 minus 6x equals -7 times 5 minus 2x, all of that plus 8. Okay. Does anybody see distributive property anywhere?
Twice.
Yes, twice. So distribute twice then for me, please. So -2 gets distributed. So that's going to give me -4 plus or minus? Plus, because this is a -6x, 12x. And then distribute the -7. So that's going to be equals -35 plus or minus? Plus, because this is a positive or a -2x. So plus 14x plus 8. Am I ready to start moving stuff, or is there one other step I have to do? Another step. What is it? Very nice. It's combining like terms. Because look here. I have a -35 plus 8 on the right-hand side. Okay? So the left stays -4 plus 12x equals... What's -35 plus 8? -27 plus 14x. You could also put 14x minus 27. Same thing. Okay? Alright, so let's start moving stuff using inverse operations. Do I want to move the 12x or the 14x? Why 12x? Because it's smaller, so I'm going to subtract 12x. So 12x minus 12x gives me 0. So on the left, I'm left with -4 equals -27 plus 2x. 14x minus 12x gives me 2x. Okay. Next step, who's in 39? Jiju. Next step. Wait, what's our goal? Okay, so if I added 4 to both sides, would that be putting my variables and constants on opposite ends of the equation? No, so what should I do? Good, add 27. Okay, so that's going to give me, let me move over here a little. -4 plus 27, positive 23 equals 2x. And then what do I do to solve for x? Who's in 27? Carla. I'm here. 23 equals 2x. How do I get x by itself? Good, I divide by 2. Because 2 divided by 2 gives me? 0. No. 1. Okay, so x equals, what does x equal? 23 over 2 is perfectly, 23 over 2 is perfectly acceptable, or 11 and a half. Either one I will accept. Please don't give yourself more work and turn it into a decimal. Okay? But I prefer 23 over 2. But if you do 11 and a half, that's fine as well.
Is there another one?
Okay, example 5. 4 bracket 5x plus 7 minus 6x plus 2 equals 2 times x minus 6. Write it down. All right, let's look at the left-hand side. Do I need to distribute or combine like terms at all?
Yeah.
Yes. Which one should I do first? Well, order of operations says we have to look inside parentheses or brackets, right? So let's combine like terms inside first. That's just going to make our distributive a little bit easier. So that's going to give me 4 bracket. What's 5x minus 6x? Negative x plus 7 plus 2 equals, I'm going to rewrite 2 times x minus 6. All right, now what do you see? Starts with a D. Distributive. So distribute the 4 and the 2. So that's going to give me negative 4x plus 28 plus 2 equals 2x minus 12. Am I ready to start moving stuff yet? Combine like terms, look. 28 plus 2. So negative 4x plus 30 equals 2x minus 12. Beautiful. Okay, which one here do I want to move? Negative 4x or 2x? Who votes for negative 4x? Raise your hand. Who votes for 2x? Raise your hand. Okay. That was lame. Let's try again. Who votes for negative 4x? That's the one we want to move. Who votes for 2x? That's the one we want to move. Okay, I know that 2 is smaller than 4, but what's the difference between those two? The negative. Move the negative because we get to add it, which means our x's stay positive. Okay, so I ran out of room. So that's going to give me 30 equals 6x minus 12.
OMG. Like,
okay. Not done yet. What do I need to do? Who's in number 2? Jocelyn.
You have to, I don't know what to call it, but you add 12.
Very good. We add 12 to both sides. That's actually called the addition property of equality, in case anybody was curious.
That's a mouthful.
I know. 42 equals 6x, and then what? Divide by 6.
7.
Everybody, what's 6 divided by 6?
7. 1.
One.
We thought we were doing the other side. We got it.
I checked them.
You need to listen to my question. So x equals 7. Example 6. 2 minus 3x equals 5 bracket 2 times x minus 3 minus x. End bracket. Write it down. All right. Left-hand side, I don't see combined like terms or distributive properties. So I'm going to look at the right-hand side. What does order of operations tell me I have to do first? The parentheses. So we have to work inside the brackets first. Do you guys see distributive property inside the bracket?
Yes.
Yeah, so distribute that 2 and everything else gets rewritten. So 2 minus 3x equals 5 bracket 2x minus 6 minus x. End bracket. Inside the bracket, I have some combined like terms. 2x minus x gives me what?
1x.
1x. So we get 2 minus 3x equals 5 bracket 1x minus 6. Okay. 2x minus 3x equals, what property do you guys see now? Distributive. So distribute these 5 to get 5x minus 30. 5 times x. 2x minus x gave me the 1x. Okay. I have 2 minus 3x equals 5x minus 30. Which of the x's do I want to move? Negative 3x or 5x? Negative 3x. So add 3x to both sides. Because the negative because that one's a negative. So we get 2 equals 8x minus 30. Okay, ladies and gentlemen, then what do I want to do? Add 30. We have to get it to the other side. That's our goal. Okay, so 32 equals 8x. Divide both sides by 8, so x equals 4. How would I check that that answer is correct? Plug it in, plug it in. Okay.